Hey, welcome to lesson 4. Today we're going to talk about speed and velocity. So just recall from yesterday, we talked about that there is scalar and vector. I'm just going to write it at the top here just as a reminder. You might want to write it out too. So scalars are a thing that has no direction. Short form direction, okay? DIR apostrophe S. Things that we have talked about that are as scalar quantities are distance, okay? So no arrow, that's distance. And distance, we count all the trip. Like if I go forward and backward and then forward again, I have to count all those distance that I've traveled. It's like a length. Okay, the other words that you need to know are called vectors. Okay, vectors are things that do have a direction. And the things that we have been talking about in terms of directions are D with an arrow, we call that positions. And that always is referred to a reference point wherever your 0 is. And a lot of time we're dealing with number lines. Okay. And then the other one is delta D with an arrow at the top. Okay, what is that called? Yeah, it's displacement. Okay, displacement, we basically only care about the starting point and the ending point. We don't care about the trip in between. So it's always measured from starting point to the ending point. So we don't care, you go in circles, you jump and go through hoops and stuff like that. It doesn't matter. All I care is where I start and where I end it. Now we're moving on to other stuff. Okay, speed. Okay, I don't know why mine doesn't show up. Speed, the symbol is a little v. I think it should be on your page. Okay, it is a scalar quantity, meaning there's no directions. And it discusses about a distance that an object has covered over a period of time. The equation is distance, which we learned how to calculate yesterday, over time. And there are different types of speed, right? We call this the constant speed, which really doesn't happen a whole lot. Can you imagine? I don't know how many of you drive. Am I safe on the road with you with the driver license? Constant speed is like you constantly just maintain at the same speed and you're not moving. Okay. More realistically is this thing called the average speed. Okay. It's very rare that for an object to be maintaining a constant speed at all. Could you be going faster, slower, whatever? So basically in this one, all we care about is what is the total distance that is covered divided by the total time. So the equation is VAV equals delta D over T. Another way that we write it, I don't even need the AV, but the key thing is you don't put the arrows on top. So this is the way that I write it more. I don't even bother with the AV. Okay, the last definition is called the instantaneous speed. Sorry. Instantaneous. Think of the word instant, root work, okay? The word instant. So right at this moment. And basically this is when you read from your speedometer wherever your speed is at this particular second. Okay, velocity on the other hand is a vector quantities. Okay, velocity is a vector, so that means it has a directions. And instead of now, so if you go back to what I was saying, vectors are the one that are these guys. So vector velocity goes with displacement, and then scalar speed goes with the distance. So hopefully that helps you remember. Okay, so vector is a velocity vector is a vector quantities, and it's talking about change in position, meaning displacement. I don't know if you recall the definition of what change in position is. Change in position is really your displacement, right? So this is displacement. So starting point to ending point. Because sometimes these questions are like a two-step question. They ask for what is the velocity. Then you have to first of all calculate what is the displacement before you can use it. Okay, so the equation for average velocity is change in positions or displacement divided by the time. And this is the equation. And just like the other one that we were, the same as speed, I don't even write the AV. I'm totally good if you guys just write displacement over time. Okay, so this is the actual one that I would use. Okay, more definition. This is totally new. Uniform motions are things that maintain the same speed and direction. Non-uniform motions are everything else. It either change speed or change direction. Okay, so I'm going to talk about, kind of give you a little bit of example. Okay, uniform motion basically is for anything that is going at a constant velocity. Okay, so if I have a car traveling at 100 meters east, that's a okay, I shouldn't say that. Okay, if I have a constant velocity, if I have a car that is driving at 100 kilometers per hour traveling east, that is a uniform motion. So what kind of question can I ask on a test or a quiz? It's if classified, I give you a whole bunch of stuff. If I say, I have a leaf that is falling from a tree, is that uniform motion or is that non-uniform motion? Okay, this one, yes, it's going down. The direction is going down, right? The leaf is going downwards. But don't forget there is acceleration due to gravity. So I'm actually not going at the same speed. So this one is actually a non-uniform motion. If I say, we already talked about this one. This one is uniform because it's going at a constant velocity. If I tell you there is a runner traveling at 15 meters per second in a track. Okay, in a circular track. I'm even going to make it more specific. If it's in a circular track, is this uniform or is it non-uniform? Go back to the definitions and read it. Okay, it is at a constant speed, but because you're going in a circular track, do you see how you're changing direction? If it's changing direction, it is non-uniform. Okay, so you're gonna have to look for, it has to be same speed and same direction for me to classify it as a uniform motion. Okay, example. So this has to do with math. I don't know how easy or hard math is for you. So I just want to be on the safe side. You might want to write this down too. Is to draw your magic triangle if you need. Okay. I'm just going to draw my triangle. I gave you two equations that are almost exactly the same. So the rearranging of the equation would be the same. So I'm just going to write V is D over T. Okay. Or V arrow is delta D arrow with a T. But in terms of manipulating, they're the same. I don't know how much you remember how to do these. Okay, if I have two things beside each other, I am multiplying. If I have things above and below each other, I am dividing. Okay, so take a look at the equation. I have V is D divided by T. Do you see D divided by T? That means D has to be at the top. Sometimes even when they don't give you a magic triangle, you can make up your own magic triangle if you understand what they mean. Okay, so I'm just going to draw a magic triangle here again. I'm going to leave that one. So I said is D divided by T, so that means D has to be at the top and T has to be at the bottom, and then that's leaving your V at the side. So how do you use this? Okay, so I'm just gonna, I don't know if I know how. Okay, I'm just going to use a shape. I'm gonna fill it in with the pink color. Okay, I don't know if I like this line color. Let's do gray. Oh, there's my heart. Oh, very smart. Okay, I just want that to cover things up. I don't know how useful it is going to be. Okay, all right. So, oops. If I have questions, whatever, like they're looking for it, and if I want to find V speed, it's like I can't show you my hand covering it, so that's why if I want to look for V, say for example, like actually, you know what, we're gonna do this example. Okay, a car is traveling at 240 kilometers in 4 hours. What are the average speed? So you have to write out your given. So meaning what they stands for. Okay, 240 kilometers. If I take a look at, is it V, D, or T? You know how you only got three things. I'm talking about a length. So this is your distance. Okay, go back. I'm finding speed, so I'm using the scalar. So I'm using this first equation right here. Okay. I have distance, which is delta D. Be very picky on your symbol. If it's supposed to be a lowercase, can you write a lowercase? Notice that I also write my units here, right? Kilometers. In 4 hours, 4 hours is your time. Okay, so I'm going to write 4 hour. I'm just going to use an H to represent it. They're asking for what is the average speed. Speed is what I'm looking for. Okay, I know in the equation they already tell you V is D over T. Okay, you can write that out. But because in this part, I want to demonstrate how to use the magic triangle, I'm just going to show you my mental process on paper, on iPad, whatever. Okay, so if you take a look at the magic triangle we drew, okay, they said that whatever you're looking for, take your hand and cover up the thing that you're looking for. Okay, so I'm just going to pretend this is my hand. I'm going to cover up the V. Okay. Do you see that I have D at the top, T at the bottom? So that means when I write up my equation, I would write V equal, because that's what I'm looking for. D is at the top, T is at the bottom. Okay, so as on the side here, we can just complete the rest of it. So this is my first form, right? V is D over T. How about if the question is looking for delta D? Okay, if I'm looking for delta D, so I'm going to start with the magic triangle again. I take my hand and I cover up the one that I'm looking for. Do you see V is beside T? So that means if I look for distance, it's speed times time. Let's do the third one because there's only 3 combinations. If the question is asking for time, okay, I cover up the time. So I'm going to take my hand. I'm going to cover up the delta T on the magic triangle. Do you see D at the top, V at the bottom? So I put D at the top and I put V at the bottom. Okay, so if you're really good with rearranging equation, you don't need the magic triangle. But if you need it, use it, right? All right, so finishing up the question. So now I have D, which is 240 kilometers. I have T, which is 4 hours. Take your calculator. I know some of you were asking me questions. I don't have the exponent button and stuff like that. I'm using my phone. If you can have access to a scientific calculator, I think it will be useful for you. I know you can use your phone, but it'll be nice to have it. So 240 divided by 4, punch it in your calculator. I got an answer of 60. Okay, the unit, do you see I cannot cancel, but km is at the top, h is at the bottom. This becomes kilometers per hour. This little slash line just means that I'm dividing. How do you get full mark? With question like that, people always do not write their equation. You get 1 mark for writing an equation. You get 1 mark for plugging in the numbers. And you get 1 mark for an answer with the unit, right? So if you miss a unit, if this is missing, you lose half a mark, right? If the equation is missing, you miss a full mark. All right, so let's do the next one. I'm going to change my highlighter back. A jogger runs a distance of 700 in 1600 seconds. Find the speed. So distance is delta D, and they tell me this is 7,000 meters. In 1600 seconds, that is my time. And they want you to calculate the average speed, which is your V. Okay, equation, you're 1 mark, right? I know you know it, you still have to write it. This is a proper way of communicating it. Okay, speed is distance over time. Check. No arrows. I'm not dealing with vectors. This is a scalar. Okay, 7,000 meters divided by 1600 seconds. 4.375. Some of you are going to ask me, how many decimal places am I supposed to keep? I think 1 decimal place is good. Okay, we're not going to talk about SIGDIG in this course. If you know it, that's great. If you don't, we're just going to move on. So just give me numbers that are reasonable. If you want to leave them all, I'll take them all. Okay? A dog runs for 6.5 meters per second. So that's not my distance anymore. For 12, and they're asking you how far. Sometimes the units can help you recognize what they are. Typically, if I'm talking about distance, I'm just writing typical unit, just so that it helps you memorize it, like kind of recognize it a bit better. Distance is the length. It could be in meters. It could be in centimeters. It could be in kilometer. Those are commonly used ones. If it's things that are measured in time, it could be in seconds. It could be in minute or hour or years, whatever that they use to measure time. Speed or displacement, it all depends on what distance unit they use, what time unit, but all the time it has to do with the whatever per whatever. It's always distance per the time. So commonly used ones are meters per second, kilometers per hour, okay? But they can use all sorts of different combination too. But the key thing to recognize it, it has the per, right? It has the dividing. Okay, so that's something to have, nice to have on the side when you're doing your problem so that you can recognize it. Okay, so it runs for 6.5. So I look at, okay, meters per second. That is my speed, okay? So 6.5. So speed is a symbol of V. And it runs for 12 seconds. Second is time. Delta T is 12 seconds. How far? So this one's asking you the distance. Is the dog running? So go back to your magic triangle. Okay, if you need it, I'm just going to draw my magic triangle again. D was at the top. Okay, I want to look for D. So cover up your D. Do you see V is beside? Like if I cover up my I cover up my D, do you see how V is beside your T? So I'm multiplying it. So I'm going to write out my equation. So delta D is what I'm looking for. V is beside T, so it's V times T. So 6.5 meters per second times 12 seconds. So 6.5 times 12 works out to be 78. The unit, I have meters per second times second. One thing to do is you can look back onto your chart. Okay, which one makes sense? I need a length. If I look at the units they give me, it is meters. The other way that you can look at it is by just analyzing the unit. I know meters per second can be written out like that. I have meters per second multiplied by second. I'm only dealing with the unit for now. Okay. What this means is the second is at the top. And if I have something that is at the top and the bottom, I can cancel them. So S and S cancel each other. Do you see how I have meters left, right? So those are called unit analysis if you want to know what it's called. Car traveling at 27.8 meters per second. That's my speed. They gave me 2. I don't know if you recall the conversion. Like to go from meters per second to kilometers per hour, I times it by 3.6. But I don't think I need it because I got the meters per second and then I got my meters. So these two already match up, right? So I think I'm going to keep with these units. And they're asking you how long, meaning your time. So I got speed, 27.8 meters per second. And they have travel, meters is distance. How long is my time? Magic triangle, D is at the top. I want to find out what is time. So I take a look at it. I cover up my delta T. So I cover this up. D is at the top, V is at the bottom. So D is at the top, V is at the bottom. So delta T is what I'm looking for. D is 50 meters. Velocity is 27.8 meters per second. So take my 50s at the top. I divide it by 27.8. This worked out to be 1.7985. So I'm going to write 1.8. The units, I'm going to challenge you to write it down. What do you think the unit for this time is? Okay. It should be in seconds. And if you want to check, I have meters divided by meters per second. Those are the units that we're dealing with, meters divided by meters per second. And in math, if you remember, whenever I'm dividing a fraction, it's like multiplying the reciprocal. I have to flip it and turn it into a multiplying. Meters at the top and meters at the bottom, they cancel. I'm left with seconds. Okay, but also, as I said, you can always just go back. What makes sense to be the time? Like, go back to this chart that you have. I know that time is measured in a single, either a minute or second and stuff. And then I go back and I look at the question. The only thing that's available is a second, so it has to be a second. Okay. I know I have been doing all these examples for you. I forgot to stress that, you know what, before I do it, I want you to try it out first, right? And you guys are watching a video. The best thing you can do for yourself if you want to see if you get something, pause the video, do it on your own first, and then check my answer, right? That's always the best one. If I punch something in the calculator, check it. I could very much be wrong all the time too. I make mistakes too, right? So a good idea is to try out the question on your own first before you just copy. Don't just copy out what I do, okay? A bird flies from a position. So not right now I'm dealing with vector now. Okay, I'm talking about position 5 meters right of a tree to a position 20 meters right of a tree. The tree is your reference point. Okay, it takes 3 seconds to fly. What is the average velocity? Okay, so it is sometimes helpful to draw like a little picture. This is 0. That's where the tree is. They tell you that you got a bird that started 5. So I'm assuming right to be my positive. I am at 5. This is my D1, my first positions of the bird, which is 5 meters right off the tree. And then you have now flying to a position 20 meters right off the tree. So I can use the same number line, right? D1 and D2. And they're asking you, it takes 3 seconds. So what is the average velocity? So I get D1, first position is 5 to the right. Write all your direction now, careful. D2 is now at 20 meters to the right. Things that I need you to check. Did you put these little arrows here? These are important, right? You have to put a direction. I'm talking about positions. Did you put your direction here, right? So those are things, important things that you need to do. In the question, they also tell you it takes 3 seconds. That's my time. And they would like you to find what is velocity. Velocity is v with an arrow. What is the equation for velocity? Velocity is delta d arrow over delta t. But you do not know what delta d is yet. 2 ways to do it. You can plug it right into this equation, or you can do it separately. I'm just going to do it separately just to make sure everybody's on board. We learned this in the last class. To calculate delta d, it is the final position minus the initial position. Put your arrows down. Okay, final position is 20. I got it from the data list here. 20 minus initial position, which is 5. So 20 meters minus 5 meters. This is 15 meters to the right. Does it make sense that I have traveled from here to here? I was at 5. I'm at 20. It's 15 to the right. So now I can throw this into here. And now I know that this is 15 meters to the right, divided by the time, which is 3 seconds. 15 divided by 3, 5. Look at the unit. The unit has meters per second. Oops. Meters per second with a direction of right. Ooh, piggy. How do you get your full mark? Let's take a look. Okay, 1 mark for the equation. 1 mark for finding me the displacement properly. You lose half a mark if you miss arrows here and there. 1 mark for subbing it in. 1 mark for an answer. So this is a 4-mark question. It's not hard to get it. At this point, get comfortable with the arrows, the uppercase, lowercase. Don't mess them up, right? Be careful. If you need, start a sheet of paper with equations and things. We'll actually talk about taking, study notes as well today. All right. So hopefully this helps.